Good day and welcome to the Math Salon. I'm Dr. Mendem and we'll be looking at some questions on complex numbers for the advanced levels. So the first question that we have on the board is express sine 2 theta in terms of sine theta by making use of De Moivre's theorem. So the first thing is maybe we remind ourselves a little of what De Moivre's theorem means. So according to De Moivre's, if a complex number is expressed in the form cos theta plus I sine theta with a unit length, then if I take cos theta plus I sine theta raised to the power n, then it's the same as cos n times the theta plus I sine n times theta. That's just the idea. So in this case, we're asked to express sine 2 theta in terms of sine theta by using his ideas. The sine 2 theta here is seen as a real number, but we also know that if a complex number z is written as a plus bi or ib, which is, then we know that the real part of z is equal to a and the imaginary part of z is equal to b, not bi. The imaginary part is b, so this imaginary already takes into account the I. So it means if we formulate a complex number as this, then the imaginary part of this will be actually this part. So it corresponds to that. So the imaginary part of this complex number is 2 theta. So it's good. It's a nice one. It's like you moving into a salon and getting your hair dyed. It's still the same hair, but you look much more beautiful. So in this case, what we do is we say, okay, if this is true, if we can write it in this form, then it means we can do the reverse version of the De Moivre. 2 is sitting in there. That means I can write it and carry the power outside and put it on top. So this is the same as cos theta plus I sine theta, now the 2, which is coming from inside there. So this is De Moivre's theorem here. If that is the case, that means I have to square this. To square this, I get the first term squared. I mean, we've learned that a plus b squared is a squared plus 2ab plus b squared. So this is the first term squared, that is cos square theta, plus 2 times the 2 terms, that is 2i cos theta sine theta, plus the last term squared. I squared is minus 1. I guess you already know that. I is equal to the square root of minus 1. So if I square I will square minus 1. And it goes away with the square root, and that's minus 1. So I squared there is minus 1, that's why I have the minus 1 here. And my sine, of course, is squared. So this is sine squared theta. It's a good thing to arrange the real terms together and the imaginary terms together. So this and this go together as a real term. And I'm concerned with the imaginary term because that is the part I'm looking for. So from this complex number, I want only the imaginary part. And that imaginary part should be written without the I already indicated here. So and that is 2 cos theta sine theta. But I was asked to give them only in terms of theta. So it means here I have to try to change cos theta to something in sine theta. But we also know from this cos identity that cos square theta plus sine square theta is equal to 1. So that means cos square theta is equal to 1 minus sine square theta. And that means cos theta is equal to the square root of 1 minus sine square theta. So I can replace it with that. And we are done for that question. The second question says, if we are given this complex number written as z plus 1 divided by z minus 2 is equal to I, where z is a complex number of the form a plus bi, then we should look for that z. So simply, we should look for a and b. And the a and b are real numbers. In this relationship for a complex number, the a and b are real numbers. So if that is the case, there are several ways you can do this. One is like saying, let z be equal to a plus bi, and you substitute here and play around. But I will look for one that is easier, and I think will not complicate your life. So if I take this one here, I can just cross multiply this on 1. So this z plus 1 multiplied by 1 stays there, and this goes with the I. Z plus 1 stays there, the I goes inside this I times z, iz, and I times minus 2, 2i. Then I try to bring all the z's together. So I can take this z to this other side and this 1 to this other side. So iz goes there to become minus iz, plus 1 comes this way to become minus 1. I can factorize z, then I get 1 minus I, and this is equal to minus 2i minus 1. Of course, I can divide both sides by I, 1 minus I, to get my z, and I'm done. The only thing is, when I divide here with 1 minus I and 1 minus I will have to make sure that the complex number is in the correct form. A complex number cannot be written as a ratio this way. All the numbers that are below have to be real. So we have to look for the conjugate of this one, and then that will be fine. So if that is true, the conjugate of this is simply changing the sign in front of the imaginary term to a plus. Mathematically, this is correct because I've just multiplied this number by 1, but I chose a nice one. The one is 1 plus I divided by 1 plus I. If I do this, I can now also multiply out. So this is 2i times 1 is 2i. 2i times I. So this is 2i for 1. That is 2i times I. Minus 1 times 1 is minus 1. Minus 1 times I is I. I times I is I squared. And we saw already that I squared is equal to minus 1. So this becomes minus 1 here. But the minus 1 and the minus 2 becomes plus 2. So I have that. This I can join with this to become minus 3i plus 2. This is the minus 1 here. So then I get minus 3i plus 2 minus 1. So 2 minus 1 is 1. If I split out the denominator, then I get, putting the real term first, of course, this is simply the same as minus 3i plus 1 on 2, which is similar 1 minus 3i on 2, and this is half minus 3 on 2i. So we've expressed our z in the form a plus bi. A is half, b is minus 3 on 2. Once again, if you enjoyed the video, please do not forget to give us some thumbs up, and most especially, please do subscribe to our channel. Thank you. Bye.